Hey, this is Sanyam Bhutani and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to Quarantine Content with Kaggle Winners, the CTDS.show. This episode is an excerpt from my complete interview with Philipp Singer, my third interview with Dr. Philipp Singer. In this excerpt, or short version of the interview, we talk about his solution to the Jigsaw multilingual toxic comment classification competition. Philipp solo gold medal in this, ranking in the 8th position on the private leaderboard. We talk about his solution, his approach to the problem, what is the problem, and what did he learn about TPUs and the other competition. The complete interview, where we also talk about his second solo gold win in the same week, will go out 1 week after this one, so please stay tuned for that. For now, here's the short version of the interview where we talk all about Philipp's solution to the Jigsaw multilingual toxic comment classification Kaggle competition. Please enjoy the show. Okay, so let's maybe start with the Jigsaw multilingual toxic comment classification. Just reading out the name for the audience if you'd like to look that up. You finished 8th on that competition. Congratulations. Can you say the challenge? It might be familiar to many because this is a familiar name. How was this different from the earlier competitions? Because I think this was a different flavor of the competition.
Yeah, there have been previous competitions. I never did any of those, so I actually don't even know much background of those. In this case, or rather, I think the difference to the previous ones was, so in general, you have data on Wikipedia. On Wikipedia, you have talk pages, which are pages where people discuss, for example, articles or changes to articles or conflicts. There is a lot going on in the background of on Wikipedia that many people don't see in the front, but there are a lot of edit wars. There is a lot of research actually about this topic, like you want to change this Wikipedia page to this sentence and others say, no, you're not allowed to. And then there's a whole discussion about just changing one sentence on one page. So there is a lot of community discussion and conflict going on in the background. And these talk pages are basically the pages where you have the people discuss these things. And there is a lot of toxicity also going on those pages. And the main goal of these Jigsaw competitions has been to classify these talk page comments to toxic or not toxic. And the gist and the twist in this year's competition was that they wanted to do it not for English, but for other languages. So previously it was always only focusing on English Wikipedia. And this time they wanted to focus on classifying 6 other language Wikipedias. So for example, Turkish, Italian, French, and so on. But they did not really provide any training data for these languages. So the goal was to train your model on English comments given from the past 2 competitions, and doing inference on new languages, not including English. So the goal was to train something on English where you have a lot of data and then do inference on different languages. And you can say this is a kind of zero-shot approach where you try to predict something that you don't train on. And this was basically the goal. The other twist was that for validation, you had a small data set of 3 languages for validation, but not all the 6. So it was very important to make a solution that is robust on those 6 languages, which basically you could only check on public leaderboard that included those 6 languages.
I think another interesting thing that I've learned so many things from you, but from this competition specifically, you've shared on the forums that you trusted your gut intuition, and you eventually ended up losing 3 positions because you didn't just pick a solution that involved a public kernel. Can you share a bit of story behind that? Because I think many people just blindly copy and fork.
Yeah. I think many people still did it, and it might be still reasonable to do. I don't know, to be honest. So what happened in this competition is that unfortunately, the whole test set was available, even though it was kind of a kernel competition. So what you could do is to just add a CSV file to your kernel, load it and submit it. And it worked also on private test. And the second important thing in this competition is that blending was really, really, really important and could boost your score a lot. So that led not only to the infamous blending and ensembling kernels that just pull up a lot of different submission CSVs, blend, and the highest scoring kernel until the end was just a blending kernel by far. And the second thing is that people, which unfortunately have observed in the past, and I personally don't like it, is publish kernels which do inference only. So they train their model externally and don't reveal the training method, but just publish the inference, which can lead to large or high scores and can net them quite some upvotes, but the complete training process is hidden. And I personally think this is bad practice, because people will never learn how those scores have been generated. And this is really, I think in general, people published really, really great kernels in these competitions, and this is the exception, I think, overall. Regardless, my best sub included one of those kernels, and I decided not to sub it because I did not see the training, and by the rules, it's also a bit unclear if this is even allowed to use such a submission. So I ended up deciding not to use it, even though I kind of knew that I will lose maybe a couple of spots. It ended up maybe 3 spots or something.
Yeah.
But I felt better about it to not select it, and also need to be a bit like, I hope something in that respective changes in the future in what kinds of kernels are published and what kind of kernels can be used.
For the audience, you have to select 2 submissions towards the end of the competition, even though usually your submissions end up getting ranked by the public score you're getting, but you have to make sure you select the 2 ones that you hope would score best on private leaderboard. So that's what we're referring to. Can you share your CV strategies for this competition? Because you said the test set was slightly public or almost public already throughout the competition.
Yeah, there was no way to do a proper CV in this competition, and that's why I didn't like the setup too much. So you only could use, in my opinion, public leaderboard to make a judgment about the models. It was by far the most robust thing to do, because it included all 6 languages that are also in private test. It ended up being just a random split from the whole test data. So it was the most robust thing to use, and I usually would not recommend to do it, but you need to also find the competitions where this is valuable, and in this case, this was the only way to do it, in my opinion. So I did not do any local CV, just subbing and public LB.
Okay. Also, we mentioned you were competing by yourself. Did you find any differences? I think this was your first, actually, the second competition where you were just competing by yourself. Any differences in competing by yourself versus in a team?
I tried one other competition before, but just a week or two, with Data Science Bowl. But in general, I think it's very different. It has advantages and disadvantages. I think advantages are that you are only responsible for yourself. And if you, for example, slack off a couple of days or decide to do something else, you don't need to have any bad feelings of letting someone down or not helping. I think this is a lot of pressure in teams that, at least for me personally, that I want to contribute something and I feel responsible for contributing something, and I need to, if I want to do something else or need to focus on work or something else, it's sometimes a bit difficult for me personally because I need to let people down. I'm not sure everyone thinks like that, but at least for me, that's the case. And if you're solo, you only have the pressure on yourself, which is also some form of pressure. And but if you decide to not do anything for a week, no one is affected by it except for yourself. So that's definitely an advantage of doing solo competitions. Disadvantage is, of course, that you are working alone and not in a team. And if you're stuck, way harder stuck than in a team. You cannot discuss things. You cannot say like any insights. I think in tweet competition, I was stuck a lot, for example, and I could not discuss with anyone and try to go out of this stucking behavior feeling. And what usually also is good in teams is that you explore different branches of the directions you can go. Like you focus on this, you focus on that. And if you're solo, you need to either explore different at the same time, or as I said, you're stuck in one direction and then you need to go back and start with another. So I think that's definitely a problem. I think the perfect team size is 2 to 3 people. I think that is the most valuable, because too many is also then again complicating things with too many different opinions, too many things to coordinate. But yeah.
Okay. I also want to discuss your solution, but you also learned a lot about TPUs. You mentioned on the forums. Maybe you can start by what you learned about TPU specifically, and
Yes.
then towards your solution overview.
Yes, so actually my main goal in the beginning of this competition was not a solo gold medal, but it was about learning about TPUs and trying to get a kernel ready that I can easily fork and run just without too much attention. Because, yeah, as I said, I was focusing on tweets and I just wanted to get something going in the meantime for Jigsaw. So get a kernel, fork it, change a few parameters, run it, and see what happens. So I spent some time in the beginning to get this TPU kernel ready. I started with TensorFlow. I started actually with PyTorch, moved to TensorFlow, moved back to PyTorch. And I figured out it's not really stable, honestly. It's very, specifically in this competition, you needed to use one of the largest possible models, which is an XLM Roberta Large, which is really a large model. And this makes things, again, very much more difficult because the RAM on the individual cores of the TPUs is quite limited. And just moving the model there and moving the data there and then doing some things is making things hard in terms of memory usage. Sometimes kernels stop randomly. So it was kind of a struggle to get something going. I tried to engage a lot with in the end, I decided to go back to PyTorch because this is my main framework I use. Tried to engage with the developers of PyTorch and XLA, which is kind of the backend for TPUs there, improving things. So my insight here is it is very promising. It can run stuff very nicely parallel, 8 cores. So if you can run even 8 folds at the same time or split the data up to 8 cores. So it is very promising technology, but it needs more refinement on the framework side to be really stable and usable, in my opinion.
Got it. Do you think it's still flaky even with TensorFlow? Because PyTorch isn't Google's native
Yeah,
ecosystem.
it's definitely more robust for TensorFlow, but still it was kind of shaky a bit, and the memory issues you get are also not 100% solved. It is probably better than PyTorch. PyTorch is catching up, but both are not perfect yet.
Okay. Okay. Now I'd love to hear about your solution overview. I think this also is a really nice chronology because your first win and your first competition was also an NLP one. So just trying to connect a few
Yeah,
dots here.
yeah, I've been doing really well in NLP competitions. My solutions in this case was, as I said, use XLM Roberta Large, train on the English data and translated training data. So the idea was to translate the English training data to other languages that you then have in tests. So for example, translate English to Spanish, to Turkish, and so on. So for one sample of English, you have six extra samples for all the other languages. Thankfully, people use the APIs that Google provide or Yandex provide and translated the data. I tried to do it myself in the beginning, but you need to have some time and do, and of course some Kaggle people do stuff so you can use it, which
Yeah.
was very nice. In the beginning, I also translated the test data and then blended. So for example, translate Spanish comment to English, score both, and then blend. But in the end, it was robust enough to translate only the train data, train on that, and do inference on the actual language. There was not much more, at least from the time I invested, and there might be more to get out. And others showed that there is more to get out in terms of model improvement. So it was no like fancy things really helped me. Rather a simple XML Roberta Large, which is really interestingly strong on different languages. I tried as many others to use monolingual language models. So for example, use a Camembert for French, use a Italian model for Italian only, and then only use those for the languages. But XLM Roberta Large was already doing the job, so no need, from my perspective, to do that. I think some people got a little bit out of it with blending, but the insight for me was the model as it is really strong. Train it a couple of epochs for on the translated data, blend many models, and then you're good to go. The main twist then was that the metric was AOC and it was calculated over all languages at the same time. So you had to find a global ranking. So for example, if Italian would be always higher than Spanish, you need to put Italian higher than Spanish.
Okay.
So there was a lot of potential to gain from post-processing, which is also what I focused then heavily in the last couple of weeks. So you could shift one language up or down and get quite good gains on the overall score. So for example, shift all Italian predictions up by 1.05 and you could get really good gains. I figured this out on CV, but testing it on those three languages that we had, but you cannot fit those scaling factors on CVE because you have 6 languages in test. So I needed to do it on public LB. Some other team, the NVIDIA team, just probed the means first and then adjusted so you can just predict one, set languages to 0 and then probe the mean, the actual toxic mean of this language, and then adjust the predictions up or down accordingly. I just directly probed or fitted the scaling factors on public LB. You had 5 subs a day. You can play with it. I started quite early, so I had some time to do it. The last 2 weeks, I basically just tried to get close to my best sub because I decided to not use, as we discussed earlier, my best sub. I couldn't fully reach it without that one model. Yeah, that was kind of the main thing, the main solution. Yeah.
How are you tracking your experience? Because Roberta takes a good amount of time to train, and I think were you just exhausting your first box that you had bought with your winning prize, or were there more was there more hardware involved?
Well, for this competition, I only did TPUs on Kaggle, nothing else. And subbing was easy because you could take the submission CSV and just play with the thresholds. Experiment tracking, I did not do much in this competition because actually really the most benefit was coming from post-processing, and I could track this very easily on Kaggle itself, but just using proper file names and maybe writing some things down. For the tweet competition, I did way more local tracking. So usually what I do is to do a simple Google sheet and note down things and track there. Still nothing. I think I mentioned this in one of the last interviews we did, that I want to get better in that. Still nothing more than using a simple spreadsheet and tracking results there. And yeah.
Most of the times, the simplest approach is also the best approach.
Yeah, what works, right?
Yeah. For someone now the competition has ended, but for someone who wants to explore transformers or just wants to learn about Roberta, do you think this is a good starting point for them? If they just jump on to the platform and look at your solution and try to replicate it, would that be a good approach?
Yeah, I think there are actually really good public kernels which try to do very robust TPU usage and use XML Roberta and do this zero-shot training. So I think that's a good way to start in this competition specifically. I think it can be valuable also for future competitions where TPUs might play a role again if you get familiar with how to use them in this competition. I feel like Kaggle is at least pushing a bit into this direction, so that's also why strategic-wise it might make sense to look into it. So yeah, just check out the public kernels and solutions. I think there's not too much magic in this competition, except the post-processing.
Yeah.
Unfortunately or fortunately, I'm not that eager of people sharing. There was not much shared. I think there was not much to share in this competition, except of course the post-processing that no one thankfully shared. So yeah, it is a nice competition to start looking into that.
Awesome. Hello again from Sanyam. This was a short part from the complete interview. Just to remind you, the complete interview, including this part and the complete overview of the other competition along with Philipp's journey and his reflections, will go out next week. So please stay tuned for that. Thanks for watching and see you again soon. Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.